in section 5.2, we're going to be looking at the bisectors of a triangle. Okay? So some unique things happen with the bisectors. And so the first one is called the circumcenter. So the point of concurrency. So pretty much the point where things intersect. The perpendicular bisectors of a triangle. So if I draw the perpendicular bisectors of a triangle, they're going to intersect at a point of concurrency. That point is called the circumcenter of the triangle. Okay, and it is the center of a circle that is circumscribed around a triangle. So this is basically what it's going to look like. This is the point of concurrency for the perpendicular bisectors of each side. Okay, and then when you do that, I can connect this point to each of the corners right there, and those become the radii of the circle. And I can draw a circle that goes around the triangle, a circumscribed circle. Okay, so let's see if we can do this. So we're going to use our compass and straight edge, and we're going to try to find the center of the circumscribed circle. So we're going to have to do a bisector, perpendicular bisectors of the side lengths. So use your construction techniques. So we start here at the corners. We got to make sure we're more than halfway. And then we make little marks up here and down here. And then without changing it, we do the same thing from the other side corner. And what we're doing is we're looking for these little crosshairs that allow me to then draw a line. And you want to try and be as accurate as you can when you're doing this, otherwise the dot's not going to line up. So all kinds of things can like mess this up. So I'm going to draw it kind of lightly because I need to make some kind of adjustments. But that segment right there is perpendicular and it bisected that side. And so we're just going to continue this for all three sides. And if everything goes well, then it will intersect at a point, which will allow me then to draw the circumscribed circle. I just need enough just to make a little crosshairs is what I need. So if all goes well, that's where it's going to be, right there where they cross. You just want to try and confirm it with the third side. More than halfway. And so all three of those should line up. And sure enough, they do right there. So that should be my circumcenter. So with that, I can use that as the center of the circle. And I should be able to then use my compass and find from the center to the corner. Now, this will be also kind of off a little bit just because of the fact that you can't get exact. And I understand that too. So when you're asked to draw these things out, you might have a little bit of a gap. But then draw your circle. Oops. And there you go. Okay. That's how we find the circumcenter and draw the circumscribed circle around a triangle. Okay. The second one we're going to be looking at is the angle bisector of the triangle. If I bisect each angle, they're going to meet at a point called the incenter. So this point of concurrency is called the incenter. It is the center of the inscribed circle of a triangle. So it'll be a circle inside the triangle. And then when I do that, these distances here to the sides are going to be the radii of the circle. So that's where those line segments came from. So angle bisectors. So let's go draw that one. So here's another triangle. Let's draw the angle bisectors. So again, you start off on your vertex. You make 2 marks. Without changing the gap, move to those marks and make a crosshair up here in the middle. Using your straight edge, connect that crosshair that you have right here with the vertex down there. Again, do it lightly. That is an angle bisector. So we just repeat that from all 3 sides. That didn't quite go far enough. So I gotta go back to this one. Okay. So hopefully that'll be it right there. And we need one more to do. And if everything goes well, it lined up. And you can see I'm slightly off. Just missed it right there. Okay. But if that's the center in there, somewhere in there, then I can use that. And I use the gap of my compass, and I should be able to match it to the side. And this may take a little bit more finesse because you're trying to match a side length. And it's got to match on all of them. This one looks pretty good. And again, any slight little error that you have will show a little bit here, but that's okay. That's pretty much how it looks. There's my incenter. Okay, angle bisectors. So you will be asked to do some constructions of these. These 2 things that I just did right here is going to be part of a project that you do that I'm going to give you here called the Euler line. And we'll talk more about that as we progress through our material. So there's that right there. The construction part of it, to actually construct those. And then the next thing down here is we got some problems that we want to look at. How I can do this work to solve problems. Use that knowledge to help us solve some problems. So in part A, if BAF is 15, this mark here told me that that is an angle bisector. This mark tells me that that is an angle bisector. Okay? They meet at that point. Angle CBF is 52. So even though my drawing is not to scale, you can still work with this. What is the angle ACF? ACF. Okay? Well, if this is the center and it goes to the center here, just like these other ones, then we're hoping that that right there is going to be an angle bisector also. okay? Because these are the equal distance here. These are the marks here. So I know that angle B, that two of those and those two and this angle down here, okay, is 180 degrees because all three angles of a triangle have to have to 180. So I know that two of these angles, BAF, and two of the angles CBF, and two of angle ACF is 180. Put in the numbers that you know, 2 times 15, 2 times 52, 2 times the angle we're looking for, and then start solving this all out. Multiply all this up, add them together, subtract it to the other side, then divide it by 2, and you'll get that our angle is 23 degrees. That's what we know. Down here, we can look at this picture over here, and we can figure out these lengths. EF is 3y minus 5. EF is 2y plus 4. What is the distance from F to side AB? So in other words, what they want to do is tell me what is that distance right there. Well, that distance right there is going to be a radii of the inscribed circle. So it's going to be exactly the same length as those two things. So I know that those two measurements are identical. I know 3y minus 5 is 2y plus 4 because that's an incenter, and these would be the radii, and they have to be the same length. Solve this for y, and I'll let you guys look at the math for that. So y will be 9. So all we have to do now is figure out that distance. So I can take the 9 and plug it into either one of those things. So I'll take the 3 times 9 minus 5, and you'll get 22. So based off of that, that's 22. And you can check this one too. If I plug it into this one, 2 times 9 is 18. 18 plus 4 is 22. Then I know that the distance from F to the side AB, I know that that distance is also 22. Okay? And so that's how I can use this information to help me solve other problems.